So what we need to do is flatten it. And again, that's one of these up here, and it's this little button that looks like two sheets. Again, you've got an option. You've got a local plane or a global plane. The global plane in this case isn't any good to us because it'll try and flatten the image, taking an average over the whole thing. We want it to flatten relative to a small area that we define. So we want a local plane, and then left mouse button, and draw as big a rectangle as you can. Try that again. Draw as big a rectangle as you can in a flat area. That's about right. Right click and it will flatten it. Now you can see it's produced a new image, and you can see that it's flatter. This terrace now is all one colour. The brighter areas are high, the darker areas are low. So you can see that that was sloping, but this is flat. And we can see the effect of that even better if we do a profile. So again, I'll do a multiple profile. I'll choose all three images. Say OK. And draw a profile down the middle. There we go. And you can see now you've got a flat terrace. You can measure heights on that nice and easily. The thing is though, that image looks horrible. And this image looks much better. So in your report, you want to think about what's going to create the best impression. And it's not really that image. You definitely want to report this profile, but you probably will want to report this image too. And that's fine, because we can see what features this profile is going over. We're not deceiving anybody, but this is giving you the accurate information. Okay, so we've got a profile. What we're going to do is use that profile on that image. The next thing we need to do is measure things on that profile. So if I click on the profile itself, you'll see the toolbar at the top changes, and there are a number of things that are useful, but the one that you really want is measure the distances. And it's this button which seems to have two vertical bars. So if I click on that, you see crosses appear here, and these measuring sticks appear here, and we can grab hold of them and move them. And the distance between them and the difference in height is given in this little box at the bottom. So you can see the distance between them is always going to be larger than the height. It doesn't tell you which is which, but you can work out from the size, relative size. So they're separated by about 7 nanometers at the moment, and the height difference is less than a single angstrom, less than half an angstrom. Okay, now, one other tip about measuring distances on here. These images are recorded point by point, and that means you don't have a huge number of points. You've got 250 square points. What that means is that if you measure the distance between 2 points and your cursor moves by a bit, you might well see a big difference in your measurement. So single measurements aren't very good. What you want is an average. So if you're measuring, say, the separation of these features running along this terrace, what we do is not measure, just grab that and
so the tip is that when the plunge is in the screen, just enter this block.
just pull that up there. Okay, I don't want to measure simply that single separation. It's better to measure as many as you can in a row and calculate it. So here we've got 4 features, so there are 3 spaces. The average distance is 3.1 nanometers, so they're about a nanometer, just slightly more than a nanometer apart. And that average will give you a better figure. Right, so once we've got these images, now what we want to do is transfer them to a report, which you're probably going to write in PowerPoint or in Word. For the images, it's fairly straightforward. We click on the image we want, and there's a copy button up here. Copy and paste, and it will go in, and the profile will be there as well. For the profile itself, it's slightly more tricky, but very slightly. When we copy and paste, what it copies are the numbers. So it copies a table of spacings, of distance against height. So paste that into Excel and plot it through Excel, and I find that better anyway, because then I can control what the plot is going to look like. Okay, only one more thing to show you with this, and that is if we go back to an image, let's go back to this image, it may be that you want to concentrate on a small feature in this image, in which case we'll want to zoom in. This magnifying glass here is the zoom, Again, there are 3 different zooms. There's the simple zoom, which will zoom in on a box that you draw on the active image. Multiple zoom, which will zoom in on the box that you draw on the active image but will reproduce on the other images you ask it to. Or there's multiple dynamic zoom, where that's the one I'll choose for the moment, where you can dictate the size of the box. So we'll take it as 30, I think, and 10. So I'm going to have a rectangular box, just for the fun of it. I can select multiple images, which I'll do. And I choose where I want to take my image. Let's suppose it's down there. Click on the screen, and then say OK. And you can see we've got 3 zoomed in images. And you can see now that there is structure around there, as well as these features that you saw there. Okay. What is that structure? What are those features? How do they relate to each other? Those are the questions that you've got to answer. Okay. So I think that's everything you need to know about the program, the data. Any questions? Okay, right. Off you go then. Go and have fun. I'm around today. I'm not here Monday, but I'm around the rest of the week next week. Don't hesitate to ask me any questions. I'll be on email over the weekend some of the time, so you can ask me through that as well. And you're welcome to work together. It's a team effort. This was a team effort when we solved the questions that we had about this. So I expect the same for you, but obviously you need to write it up individually. Okay, thank you.